Hi, I'm Dilara Gökay. We propose Graph2Pix, a graph-based image-to-image translation framework. This is a joint work with Enis Simsar, Efe Anlatıcı, Alper Ahmetoğlu, Atıf Emre Yüksel, and Pınar Yanardağ. We propose a novel image-to-image translation method that takes multiple images and their corresponding lineage structure and generates the target image as output. To propose a general solution, our framework assumes a graph structure and considers the tree structure of lineage data as a subcase. We apply our method on ArtBreeder, a popular creativity platform based on images generated with GAN models. To the best of our knowledge, this is the first image-to-image translation method that uses a graph-based structure. ArtBreeder is a collaborative platform where users can modify and create new images. In ArtBreeder, users can create images using either BigGAN or StyleGAN models. To create a new image, users can combine multiple images, as you can see on the right. Here, starting from the bottom, there are two pairs of images. Each pair has been combined to create the new image. This example has 3 levels, but it could go many levels further, thus creating a deeper lineage structure. In this paper, we investigate whether we can take such a lineage structure, exclude the child at the top level, use the ancestors such as parent and grandparents as input, and generate the child image. Pix2Pix is a conditional adversarial network which has been proposed as a solution to image translation problems. Pix2Pix HD, as the name suggests, generates high-resolution images and is a conditional GAN like Pix2Pix. The figure below shows the generator for Pix2Pix HD. G1 is a global generator, and G2 is the local enhancer which ensures the high-quality output. We have built Graph2Pix based on Pix2Pix HD. ArtBreeder has a lineage structure, but it isn't entirely clear how such a structure can be used in GAN-based models. We could consider using something similar to Pix2Pix HD directly, but it only takes a single input image and cannot consider multiple sources. Therefore, we propose a graph convolutional network-based approach where the relationship between the members of a family is represented as a graph. The figure below shows the high-level architecture of Graph2Pix. On the left side, there are multiple ancestors labeled with the letter A. These ancestors are encoded and placed as the nodes of the GCN. From the output of the GCN, we take the feature for the child node, pass it through a residual block, and transpose convolutional layers. On the right side, we have the discriminator. Unlike the discriminator of the Pix2Pix HD, our discriminator takes the concatenation of multiple ancestor images and the generated image as input, and outputs whether the generated image is fake. Here, we visually compare our results with Pix2Pix HD, and you got it. For consistent comparison, we only feed the first parent, which is parent 1, to the competitors and evaluate how well they could use this information. The first level ancestors, parent 1 and parent 2, are shown on the left, with the ground truth image labeled as child. The first observation is that You Got It generates almost identical images to the parent and does not learn how to transform from the parent image domain to the child image domain. For example, the result on the bottom left. We think this is due to the unsupervised nature of the model. On the other hand, we see that Pix2Pix HD is able to generate images that are different from the parent image, but it fails to generate images that are close to the ground truth. Since our method is able to consider both the parent and its ancestors, it obtains a result that is closer to the ground truth. To test the qualitative performance of our method, we conducted a study with 60 participants. Participants were given a pair of source and reference images and instructed to choose between the candidate images. Of course, the order of the results is random each time, so the participants had no idea whether an image was produced with Graph2Pix or, for example, Pix2Pix HD. We used 50 images in this study, and we showed the results of the top 2 competitors along with Graph2Pix, Pix2Pix HD, and you got it. We excluded CycleGAN because it produces very similar results to you got it, as you can see on the examples on the right. The bar chart on the left shows how many times a method was preferred. The horizontal axis is for each image, and the vertical axis shows how often a method was preferred for a particular image. Our method received the majority of the votes, shown as the light blue bars, followed by Pix2Pix HD. For example, as you can see from the highlighted place, users preferred 19th image 66% of the time, while preferring Pix2Pix HD 7% of the time. For quantitative evaluation, we compare our method with Pix2Pix HD, CycleGAN, you got it, MSGAN, and Pix2Pix. We used Learned Perceptual Image Patch Similarity, LPIPS, Frechet Inception Distance, FID, and Kernel Inception Distance, KID. For these 3 metrics, a lower number indicates better performance. We also included the results of the human studies. This column indicates the preference of a method, so a higher number indicates better performance. As you can see, our method achieves the best performance in all the metrics. Although the gap between our method and you got it is small for FID and KID scores, the gap becomes significant in LPIPS and human studies. Our method is not only limited to generating images from ArtBreeder. Due to the flexibility of the graph structure, our method is also applicable to any scenario where multiple images need to be translated into one, such as multi-source human image generation. We used the images of a cloth on a model from 3 different views: front, back, and close, as input to the Graph2Pix. Then we generated the image of the cloth itself, and to see if having multiple input images indeed improves the performance, we compared the FID score of the results when we used an image from a single view with FID score of results when we used images from multiple views. As you can see, using multiple inputs improved the image generation. There are some limitations with our method. For example, we observed that Graph2Pix does not perform well when the colors of the parents' images vary significantly. The figure below shows such cases. For example, the top row shows 2 parent images with predominantly different colors. Graph2Pix cannot produce an image close to the ground truth in this case. In summary, we propose Graph2Pix, an image-to-image translation method suitable for images that form a graph structure. Graph2Pix outperforms its competitors such as Pix2Pix HD and you got it, and improves LPIPS, FID, and KID scores. We also qualitatively evaluate our method. The user study showed that users preferred Graph2Pix results 81.5% of the time. Our method is not limited to ArtBreeder and can be applied to other use cases where multiple images need to be translated into one, such as multi-source human image generation. Our implementation is available on GitHub. Thank you.